Hi, I'm Bob. Welcome back to 5 Minute Econometrics, an econometric tutorial series focusing on fundamental concepts, econometric models, and estimation methods. In today's topic, we will explore binary variables, dummy variable traps, and the interpretation of the coefficients for dummy variables in a regression model. Let's get started. Binary variables are also called dummy variables. Many variables used in econometric models are binary in nature, such as whether a person is female or not, whether a person is married or not, whether a worker joins a union, and whether a firm is state-owned or not. A binary variable takes on two values, usually 0 and 1, to indicate these qualitative features of individuals or firms. In other words, we classify all observations into two groups, identified by two values, 0 and 1. For example, the variable female contains two values. If it equals 1, the person is female. If it equals 0, the person is male. Similarly, the variable married also contains two values, 1 for married individuals and 0 for all other individuals whose marital status is not married, including those who are single or divorced. Binary variables, also known as dummy variables, represent qualitative factors. By contrast, continuous variables describe quantitative factors. In this dataset, age, log hourly wage, and years of schooling are continuous variables. They can take many values. When we use binary variables as explanatory variables in the model, we should be careful not to fall into the dummy variable traps. The dummy variable trap refers to the scenario in which we include two binary variables in the model that form a perfect collinear relationship. For example, another binary variable, male, equals 1 for male workers and 0 for female workers. If we include both female and male dummy variables in the model, along with an overall intercept, we fall into the dummy variable trap by introducing perfect collinearity. The dummy variable, female, is a perfect linear function of the dummy variable, male. It is redundant to have both in the model. Stata can automatically correct the mistake. It will ignore one of them. Next, let's discuss the coefficients of the binary explanatory variables with a simple regression model. The population average of the log hourly wage equals beta 0 plus beta 1 when the binary variable female equals 1. The population average of the log hourly wage equals beta 0 when female equals 0. Thus, beta 1 is the difference in the average of the outcome variable between the two groups described by the binary variable. Here, beta 1 is the difference in wages between female and male workers. In this regression, the OLS estimated coefficient for the binary variable female is minus 0.12. It means female workers earn 12% less than male workers on average. We can use binary explanatory variables in regression models to evaluate the effects of programs or policy interventions. For example, the binary explanatory variable chain indicates participation in a job training program. Chain equals 1 means a worker participates. Chain equals 0 means the worker does not. To find the effects of job training on worker productivity, we can include the binary variable chain as an explanatory variable in the model along with other control variables. The OLS estimated coefficient for job training is 0.24. It suggests that, on average, workers who received job training earn 24% more than those who did not, holding other relevant factors constant. The coefficient is significantly different from 0 at the 5% level. Binary variables can be used not only as explanatory variables, but also as outcome variables. The model is called the binary response model or the binary choice model. We use binary response models to examine the probability of an outcome that occurs. Here is a binary response model for the probability of joining the union as a function of individual economic and demographic characteristics such as hourly wage, marital status, and whether living in the South or central city. The outcome variable, union, equals 1 for union workers and 0 for non-union workers. In a linear probability model, the coefficients represent the average marginal effects of the explanatory variables on the probability of the outcome, such as the probability of joining the union in our model. $1 more in hourly wages increases the probability of becoming a union member by 1.2 percentage points. The probability of joining the union for workers living in the South is 12 percentage points lower than other workers. Workers living in central cities are 9 percentage points more likely to become union members than other workers who are not living in central cities. Marital status has no significant effect on union membership. Today, we have explored how to use binary or dummy variables in regression models and how to interpret their estimated coefficients. I hope it helps. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.